Okay, so this is from section 3.3 on page 288 in the latest edition of the Lippin book, Living Rasmussen book. Okay, and what I want to do with this video is show you how to convert back and forth between continuous growth model and an annual growth model. Because sometimes one's easier to work with, and you know, so on. So let's go this way. So we've got an annual growth model right here. The reason I know this is an annual growth model is because there's not an E for a base. So if I'm going to write this as an exponential growth model, the initial value is the same. We don't know what E is. Well, we know what E is, but we don't know what the K. Actually, let me back up a little bit. We know the A is the A, but what's different is this part and this part. Okay, so that's the 300 is the same, the T is the same. We just got to figure out what 0.91 changes it to that exponential growth constant. So what we did, this is in section 3, so you've learned about logarithms. So I'm just going to focus on this part of the equation. Now, what unlocks that K, that exponent that we want, is taking the natural log, because this is the base E, natural log cancels out base E. So we're just going to grab our calculator, and I'll write it over here, E to the K. So what you got to remember, so some math behind it is we've got to here. Let me move this up. Let me move this up. If we take the logarithm, we can use that exponent rule. So K, we can bring the K down in front, and ln E. And then all this is what do we have to raise E to? What do we have to raise E to get E to the first? And that happens to be 1, right? Because if we rewrite this as an exponential, E to the first equals that answer, E to the first. Okay, so that's why ln of E to a power is just the power. So what we have left here is K, and what's the natural log of 0.91? Let me see. I'm going to just grab a calculator. So ln of 0.91, I'm getting negative 0.09431, enough decimal places. Now, why is that important that it's negative? Because this is a decay model, so the K will have to be negative, that constant. So 300 e to the negative 0.09431 t is what that is as a continuous growth model. I mean, you can certainly try, if you go back and try, if you want some more practice with that, you've got 59's the answers in the back, okay? Now let's go the other way. Let's go with turning a continuous growth model into a annual growth model. So it's the same deal. We'll get 150. Oh, wait a minute. 150 e to the 0.06 t has to be the same as 150 times some base to the t. So e to the 0.06 has to be equal to the base. Well, we don't need logarithms for this one. We're just going to raise e to that power. So on my graphing calculator, I do second ln, and then I can type in the 0.06. And I'm getting 1.0618. So 150 times 1.0618 to the t power. If I were going to ask you what the annual growth rate was, we do, remember the b is equal to 1 plus the rate. So 1 plus 0.0618, so that'd be a 6.18% solution or growth rate. And I know this one's growth because number one, this is positive, so it's growing, and that number is bigger than 1, so it's a growth model. Okay. Hopefully this helps you answer. Did some open math questions in section 3 4.3 that asked this. Okay. Hopefully this helps.